We are starting exercise 1.2. Okay, the first question is, which of the following are examples of null set? So we have to first understand what is a null set. So null set is nothing but a set with only one element, only one member, which is phi. So there is no other element other than phi in a null set. Alright, so we have to find out of the given options which all are null set. So here in the first option there is a set which says that set of odd natural numbers divisible by 2. So there are two options given, not two options but two conditions given. The first condition is the members of this set is odd natural numbers. So odd natural numbers, and also that should be divisible by 2. Divisible by 2. So first odd natural numbers are like 1, 3, 5, 7, 9, etc. And divisible by 2 is something like 2, 4, all the even numbers, 2, 4, 6, 8, and so on. So the set should, fulfill both the conditions. It should be the odd natural number and it should be divisible by 2, which is not possible. Like, we cannot find a number which is odd at the same time divisible by 2. So the only element in this set is phi. So this is a null set. Next example is set of even prime numbers. So we have to find a number which is both even and prime. So even and prime. So 2 is a number which is even, like 2, 4, 6, which is divisible by 2, and at the same time this is also a prime number because the factors of 2 is 1 and 2, and the number has only 2 factors including 1, so it is a prime number. So here this set is 2, but this set is not equal to the set consisting phi, so this is not a null set. Next example is x is such that x is a natural number, and x is less than 5 and x is greater than 7. Okay, so here another set we have in third condition. We need to find a set of natural numbers where x is less than 5. So a number which is at the same time less than 5 and also greater than 7, which is not possible. At the same time any number cannot be less than 5 or greater than 7. So this condition cannot be fulfilled with a natural number. So in fact the only element of this set is phi. So this is also a null set. Now we have the last option which says that y is such that y is a, this question, the question 4, y is such that y is a point common to any two parallel lines. So y is such that y is a point common to any two parallel lines. So there is no common point of two parallel lines. Two parallel lines never meets, so there won't be any common point. So we can simply say it is not possible. So phi is one such element which is common, and phi is nothing. As you know, this is just an element of a null set. So this is also a null set. So out of these 4, only second is not a null set. Otherwise all the 3 options are a null set. Which of the following sets are finite or infinite? So in question 2 we have to find out which of the following sets are finite and infinite. So about finite and infinite sets, it's very simple. Finite sets are those sets the members of which are finite. So in a set, if there are members which can be counted okay, which are finite in counting. So which of the following sets are finite or infinite? Very easy. Finite sets. First of all, we have to know what are finite sets. The number of the members of a set is finite, then the set is a finite set. It means if we can count the number of the elements of a set, then it is a finite set. Suppose in the questions given, first question is the set of months of a year. So we can count the set of months of a year. So months of a year is from January to December, which is 12 in number. So total number of this set is 12. So it is finite. It is a finite number. So that's why first set is finite set. When we come to the second question, which has elements 1, 2, 3, and then it is going on like that. So this is natural numbers, and there is no end of a natural number. It is uncountable. So if the numbers of the member of a set is uncountable, then it is an infinite set. So second one is infinite. Again, third option is 1, 2, 3, and we are going on like this, and then we have 9900. So this is again a set of counting numbers, a natural number, but from 1 to 100. So this is a finite number. Here it is also a set of natural numbers, but like there is no end. We can go on with the counting, but here we end at 100. So this is finite in number. So this is a finite set. Fourth option, the set of positive integers greater than 100. Positive integers greater than 100. So if we'll keep on going like 101, these are positive integers greater than 100. So there is no end to this. Again, we are going to form natural numbers, okay, which has no end. Like we can, it is uncountable in number, cannot be counted. So this is again infinite set. So fourth option is infinite. Now we have fifth question, the set of prime numbers less than 99. Again, prime number, the least prime number, the lowest prime number is 2, and we have to find other prime numbers. To form this set, we have to find other prime numbers which is less than 99. So when we talk about less than 99, 97 is one prime number which is less than 99. So all the other prime numbers are in between these two prime numbers. So it can be easily counted. So this is again, if it is counted, then we can say that this is a finite set. So with this we conclude question 2. Now we come to question 3. Alright, so the third question is, state whether each of the following set is finite or infinite. Again, in this question we have to deal with finite and infinite set. So there are three sub questions. So the first part of third question is set of lines which are parallel to the x-axis. So there is some x-axis which has 0, and on the right hand side it is like positively going on, increasing. On the left it decreases. So here we are dealing with the set of lines which are parallel to x-axis. So there can be numerous set of lines, there can be numerous lines which are parallel to x-axis, and it is like infinite. There is no end to it. Okay, we can go to any of the y level and we can draw a parallel. So in this way we can simply see that there are many lines which are parallel to the x-axis. In short, we can say there are infinite lines parallel to x-axis. So the first set here is an infinite set. Okay, then second is the set of letters in English alphabet. In English alphabet we have fixed and finite number of letters, like it starts from A and it ends to Z or Z. So there are 26 letters in English alphabet. So in the English alphabet we have countable number of elements if we take it as a set. So this is a finite set. The third question is the set of numbers which are multiple of 5. So multiple set of all numbers which are multiple of 5. There can be numerous, there can be endless numbers. It starts with 5, 10, 15, and like this we can go on, and there is no end. We can go to infinity. Okay, so that's why this is an infinite set. Alright, so we conclude the third question. There are two more questions in the third. There are two more sub questions in third question. Fourth one is the set of animals living on earth. Is it a finite number or infinite? It is a finite number. We can count these numbers. So this is a finite set. And set of circles passing through the origin 0. So this is your origin 0, and we have to see how many circles can pass through this 0. So there can be numerous circles. There is no end. Okay, there is no end. Actually, infinite number of circles can pass through 0, 0. Alright, so we can say that this again is an infinite set. In fourth question, we have to match the first column and the second column, and here we see that there are sets given. A elements are A, B, C, D, and in B the elements are D, C, B, A. So is A, B, C, D is equal to D, C, B, A? Then the answer is yes, because order is not at all important. So if we write it as D, C, B, A or B, C, A, D, it means the same. So here in first we can say that A is equal to B. Second question is, now second question is A is given. Okay, we have to rub this first. Now in second question A is given as 4, 8, 12 and 16, but B is 8, 4, 16 and 18. So here we can see that 4, 8, 16, 4, 8, 16 is common, but here 12 is not common in out of these two. Here we have 18. So there are two different elements, or two elements which are not common in these two sets. So we can simply say that here A is not equal to B. Third we have A is given 2, 4, 6, 8, 10 in roster form. The elements are written, and in set builder form we have X is such that X is positive even number less than or equal to 10. So X is such that X is positive even number. So positive even numbers are 2, 4, 6, 8, something like that, 10, 12. But it also says that the number should not be more than 10. So it should be less than or equal to 10. So 10 can be included, but it cannot go further 10. So 12 is not included. So this is the set B, and we simply see that set A is equal to set B because all the members of set A are in this set B, and all the members of set B are in the set A. So that's why we can simply say that A is equal to B. So what we have to keep in mind that when we solve this kind of problem, that all the members of set A should be in set B, and all the members of set B should be in set A, should be the member of set A. The last question here is X is such that X is a multiple of 10, and B is 10, 15, 20, 25, 30 and so on. So here we see x is a multiple of 10. So multiple of 10 is something like 10, 20, 30, 40 and so on. But in set B what we see is 10, 15, 20, 25. So this 15 and 25 and so on, these numbers are not here in set A. So that's why in fourth question A is not equal to B. Alright. Again in fifth question we have to find out the sets are equal or not out of the following pairs of sets, and we have to give reason as well. So the first question has a set A, which the element of this set is 2 and 3, and then we have set B, which says that x is such that x is solution of x square plus 5x plus 6 is equal to 0. So x square plus 5x plus 6 is equal to 0 can be written as x square plus 3x plus 2x plus 6 is equal to 0, and we can take common x plus 3 plus we can take common 2 here, and then we have x plus 3 is equal to 0, and then we have x plus 3 and x plus 2 as factor of this equation, which gives the value of x is as minus 3 and x as minus 2. So the elements of this set B is minus 2 and minus 3, and we can simply say that A is not equal to B because the elements of A is 2 and 3, positive 2 and 3, and element of B is negative 2 and 3. So A is not equal to B. Now the second question is A is equal to x is such that x is a letter in the word follow. So first we take this word follow, and now we find, or we make a set out of this word, the letters of this word. So when we make a set, we don't repeat the same element, so we'll take only once, we'll never repeat the elements. So if we try to write the elements of this set, which are the letters of the word follow, then we will take F, and then we will take O, and then we will take L. We are not going to take second L because one L is enough, and we are not going to take this another O because O is already here, and we'll take W. And when we come to set B, which is Y, says that Y is a letter of the word wolf. So in wolf we have these 4 letters, and if we want to write it in set form, we'll take W, we'll take O, we'll take L, and we'll take F. And finally we see that elements of A is equal to elements of B because all the elements of A is in element of B in the set B, and all the elements of set B is there in the set A. So A is equal to B. Now sixth question is from the set given below, select equal sets. So we have to find out what all sets are equal. So here A we see that it is 2, 4, 8 and 12. And if we go through all the sets, we don't find it equal to any of the other set. So A is quite unique. Then we go to B. B has elements 1, 2, 3 and 4. And when we check D has also the same elements 3, 1, 4 and 2 in different orders, but the elements of D is also the elements of B, and the elements of B is also the elements of D. So B is equal to D. Then if we check E and G, we find that E is equal to G. Alright, and no other sets are making equal pair, so we have only these 2 pairs. B is equal to D and E is equal to G. So with this we are concluding this exercise, which is exercise 1.2. Okay, so all the best. Thank you.